Hi guys, it's Mrs. Todd again, and today we're going to look at scientific notation. Scientific notation is used for very large or very small numbers. It is a common method for expressing numbers in scientific fields such as astronomy, which uses very large numbers, or microbiology, which uses very small numbers. Scientific notation is always composed of a number c multiplied by a power of 10. We have a diagram over here that helps you to see the format. You'll always have this first number that we refer to as c. That number has a rule. It has to be a number from 1 to 10, but not including 10. Then it's just simply times 10. So the base is always 10. That's why we call that a power of 10. And it's raised to an exponent, and that exponent has to be an integer, not a decimal or fraction. The following are common numbers written in scientific notation. Try to see if you can find some type of problem. So if we have 1/1,000th, that looks like 0.000001, which is the same as 10 to the negative 6 as the power of 10. In scientific notation, that's 1 times 10 to the negative 6. As you scroll down, you'll notice that every time each number is getting bigger by 10, and look at what the exponents are doing. You'll see the exponent raised by 1. Okay? See if you can find some other patterns. All right, so after you've looked at it, hopefully you saw this. If a number is between 0 and 1, those decimals, the exponent of the base 10 always ended up being negative. If a number is greater than 1, okay, the exponent of the base 10 always ended up being positive. And that's a rule for scientific notation. So now let's look at how to write numbers into scientific notation. Step 1 is you need to identify the initial location of the original decimal point. We're going to focus on decimal points. Then you're going to identify the final location where you're going to put that decimal point, known as the destination. The final location of the original decimal point must be directly to the right of the first non-zero number. Then you're going to move the original decimal point to that location. You will get a number here called c. Its value must be greater than or equal to 1 but less than 10, but does not include 10. Step 4, you're going to determine the exponent. Count how many times the decimal moved from its original location to its final location. When the original number was larger than 1, the exponent is positive. When the original number is 1, the exponent is 0. When the original number is less than 1, the exponent is negative. Then you're going to write the c value that you came up with, multiplied by some power of base 10. It should look something like this, 8.5 times 10 to the negative 5th. Now, after going through those steps, I don't expect you to have this down yet. Let's look at some examples and think about each step as I do it. All right, so write 14,987,000 in scientific notation. So I've got to identify where's the original decimal. It's right here. Then I need to identify where am I going to move the decimal to? What's going to be the final destination? Well, it's got to be directly to the right of the first non-zero number. Okay, so it's going to go there. Then remember, I have to count or move that decimal. So 1, 2, 3, 4, 5, 6, 7. And it was just natural for me to count as I do it. So when I move it there, I'm going to write that number down. That'll be my c value. It ends up being 1.4987. I drop those zeros because they're not necessary in this decimal number. Then we write it times a power of 10. And now our exponent is based on how many times we moved it and what was the size of the original number. Okay, the size of the original number was a number bigger than 0, so I leave my exponent positive. I moved it 7 times, so the exponent becomes positive 7. And that's it. I went through all the steps, and now I have that number in scientific notation. All right, example 2. Identify the original decimal. Identify where the final location is going to be, or the destination. Remember, find your first non-zero number, so the 6, and it's got to be directly to the right of that. Okay? Now I move it, and I get 6.87. That becomes C. I write times 10. To come up with the exponent, think of the size of the original number. This time it was less than 1, so it's got to be negative. And then how many times did I move it? I didn't count out loud this time. It was 1, 2, 3, 4, 5. So it's negative 5. My answer turns out to be 6.87 times 10 to the negative 5th. All right. Now I want you to pause and I want you to work the try these, letter A and C. And then you'll have some questions to answer. All right, let's look at how to go now the other direction. Say you start in scientific notation and now we need to go to standard notation. That means a normal number. You're going to copy the C part of the number. Just copy it down, okay? Then you're going to move the decimal the same number of times as the value in the exponent and in the direction the sign indicates. Remembering, negative exponents represent small values. So if that exponent is small or negative, move it in the direction that causes the number to get smaller. Positive exponents represent large values. So if it's a positive exponent, move it in the direction that causes the number to get larger. All right, let's look at some examples. Okay, copy the C. Now we're going to move that decimal, and nope, I'm going to erase this first because I looked ahead and realized I didn't give myself enough room. I'm going to copy the C here. What I noticed is that decimal was negative, so I'm going to have to move it to my left because that's the direction that will make this a small number, something less than 1. So when it's negative, move it in the direction that makes it get smaller 6 times. So there's 3, 4, 5, 6. We do loops so that we will know how many spaces need filled in with zeros. And then we always have that beginning 0. So now 8.94 times 10 to the negative 6 in standard form is equal to 0.000000894. All right. Now our second example, write 2.1 times 10 to the 8th in standard form. So that's a positive exponent, so I'm going to write it to where it gets larger. So copy the C, 2.1, move it in the direction that causes the number to grow. There's 5, 6, 7, 8. Fill in the empty places with zeros. And then now let's write it out. It's 2, 1. And I should have 1, 2, 3, 4, 5, 6, 7 zeros. And then this one's got to have some commas in there. That is 210 million. Well, I was going to say dollars, but it's not dollars, is it? Wish it was dollars. That'd be nice. All right. Now what I'd like you to do is pause the video and try these, letter B and D. All right, your answers. To A, it should have turned out to be 5 times 10 to the negative 4th. It's also okay if you wrote 5.0 times 10 to the negative 4th. Same thing. B, 15,680. C, 1.273 times 10 to the 3rd. And D turns out to be 0.12. All right, you're now ready to go to ConnectEd. and work on your practice problems. If you get stuck on any of them, please don't hesitate to ask. Good luck.